Thank you for joining us for today's presentation of the Yaskawa webinar series. I'm Greg Smith. I'm a member of the marketing team at Yaskawa Motoman. For those joining us for the first time, we present every couple of weeks on average on subjects ranging from new products to emerging industry trends and support topics. We invite you to attend our future webinars. Just a couple of announcements before I introduce today's presenter. Everybody who registered for this webinar will receive an email afterwards with a video replay link and a link to our webinar archive on our website. Might be a couple hours before it appears on the website though. If you have any questions at any time, submit them via the chat console. We'll have a Q&A session at the end of the conclusion of the presentation. We also have moderators on the sidelines who can answer any problems you might be having with technical issues, connections, and things of that nature. Today's topic is MLX300 overview and cost savings advancements. And our presenter is John Elliott. John is the Associate Chief Engineer in Yaskawa's Product Solutions Group. He's been with the Yaskawa team for 24 years and has over 3 decades of experience in robotics. So welcome, John, and you have the stage.
Thank you, Greg. Good afternoon, everybody, and welcome to the MLX300 overview and cost savings advancement. The focus of this WebEx is really to introduce everybody to the new MLX feature of using a robot pendant to teach points to the PLC. This development started out as a simple solution of just teaching points, but we advanced it to provide a more complete solution where you can use the robot pendant to teach employee mode operations for the MLX300. I know there's a large number of attendees that are new to the MLX product. So I'd like the first half of this presentation, I'm going to explain the MLX300 and how it can be used to differentiate your application solution for numerous advantages. So we're going to start with that. We're going to do the overview of the MLX300. And in the second half, I'll explain the new teach pendant on the new teach screen on the robot pendant. The MLX is a control platform that empowers the PLC to completely control the robot with the ladder logic. The PLC will cue motion commands up to the robot controller, and the controller will execute the superior motion kinematics. That's true, most systems already have a master PLC controlling everything in the cell, but the MLX advantage is you only have one programming language. Everything can be done in the PLC ladder compared to a traditional integration where you'd have a PLC programmer and a robot programmer. The extended benefit is for customers or companies that don't really use robots yet. They can quickly come up to speed on integrating a robot into their production with minimal training. The PLC programmers are working in their environment, and all we're doing is adding a few extra tools or AOIs so they can configure and control the robot. The MLX is available on any robot on the DX200, YRC1000, or the YRC1000 microcontrollers, with the exception of the HC1020 collaborative robots. This platform is ideal for picking, packing, palletizing, and machine tending. The MLX300 diagram shows that any Rockwell Compact Logics or Control Logics PLC with at least 2 megabytes of memory, and this PLC is connected to the robot controller and other devices in the cell with Ethernet IP. There's usually an optional HMI, such as a PanelView for play mode operations and messages. And in the past, there was a requirement that you had to have a MLX pendant to perform teach mode operations. And this could be a ProFace or a MobileView pendant. Note that this is a 3rd generation of the MLX. It's been around for a while. The MLX 100 and 200 used a panel of amplifiers, Yaskawa amplifiers. But the MLX 300 uses the actual robot controller, which makes hardware debugging much easier. You can switch the controller to the non-MLX mode by just turning the key switch. It's like remote would be MLX and teach and play would be this conventional robot controller. So it's easy to go for our service guys to go in and do preventive maintenance and service on this type of solution. A single controller can be configured to operate up to 4 robots, or external axes. This is accomplished with a standard Motoman kit that actually combines multiple controller cabinets together, and only one of the CPUs is used to operate the robots, all the robots. For example, a DR2C is dual robots and 2 controllers. In this picture here, it's simplified. I'm saying TR3C. This is actually 3 controllers, but only one controller CPU is running the other controllers. A combination of up to 4 robots and external axes can be configured. In the PLC tags, an external axis is really a document or stored information stored as one of the robots. So it takes a robot position. Therefore, like a max configuration would be 2 robots operating on a servo track with 2 transporters. The external axis could be a servo track, a servo gripper, or a multi-axis positioner. We have an integrator right now that just installed an MLX300 that had 2 robots on the same track, picking parts from 29 stations and placing them on multiple conveyors to queue up parts for our cabinet assemblies. Both these robots could access most of the stations, and there was dynamic collision avoidance between the robots and tools. The MLX300 we provide screens for the PanelView, the mobile view, and ProFace pendant. Here's some example screens. You got play mode operations, IO status, setting up a user frame and interference zone, teach screen, and IZ status screen. The HMI software is not locked down, so you can customize it for a tailored look and layout. This shows the MLX300 components. On the left side is the typical configuration, and on the right side it shows what we usually ship from Motoman. The controllers come with a pendant, an external e-stop button, an MLX auto manual key switch. And we configure this so the integrator can buy all the PLC and HMI hardware from their local vendors and get the discounts that they have to avoid additional markups. So this will help make the final pricing to the end customer more competitive. Note that to use the MLX pendant, the robot pendant needs to be removed, and the cable shown in that picture coming out the side of the cabinet needs to be connected to the standard pendant port. This cable will provide power to the MLX pendant and connect the safety circuit. This design, we did this because it enforces single point of control. You can't have 2 pendants connected at the same time. Next, we'll talk about the MLX300 AOIs, which are function blocks for the PLC. The MLX includes over 50 AOIs. Many of the AOIs are used for the standard HMI screens and aren't really needed for a typical customer application. The AOIs are for jogging and moving the robot with linear or axis motion. They could be to an absolute position that you taught, or it could be to a relative incremental position. There are AOIs to set up tool data, user frames, shifts, and interference zones. There are system state commands that can enable servo power, abort, hold, and restart the robot. On the right side in green, we've shown some new AOIs that are getting ready to be released. For collision detect, you can have 8 different settings. So if you're getting close to a part or something delicate, you want to make it real sensitive. If you're doing air cuts, you can have stronger settings. There's a brake release coming, servo float, and circular motion command. This shows a typical example of a simple move command. It's an axis move. When the robot step equals 200, the robot will move to the approach pick position. When in the command, you can set the robot number, the blend factor, the speed, the acceleration, and a controller number. At the bottom, you'll see MLX 0. That's the first controller. There are multiple outputs on the side, but the one that you really want to use most of the time is the status PC. When the process complete bit is on, the motion is complete, and in this example, the logic will move you to the next step. There's also a step continue contact shown that it's optional. If you put that next after the move command, you can actually single step it from the HMI. Now, when you teach a point, the data is stored in the application data tags under the robot number and a teach point number. A job number and a teach point number, as shown on this HMI. And then the job number is just a list of points. You have multiple job numbers. And after teaching the point, it can be inserted into a motion AOI as a target position. And this is shown on the right side. It's a job 2, teach point 12. So in the application data tags in the ladder program, you'll find the data for all the teach points, the tools, user frames, interference zones, and conveyor tracking. This shows an expanded view of the teach point data for job 1, teach point 1. And in this, in the middle, you'll see the TCP data stored. It's X, Y, Z locations plus the pose angles. And then you'll see the axis data, which is really the angles per axis. At the bottom, you'll see a user frame number and a tool number that this point was taught with. Note that the PLC can easily generate this point data without actually teaching the point. For example, we have a solution called Palette Solver, and you just teach one point, the home position. And it can run 4 build stations, 4 in-feeds, and 2 dispensers. And what we do is we teach user frames for each station, and we can define, passing over those stations, distances, and you can automatically generate all these positions for the whole program. On the left side, you can see that this ladder is set up for 4 controllers. Down at the bottom in the IO config, there's 4 controllers set up. And then each controller has a Pendant operation program, and that's this new feature I'm going to talk about here soon, and a communication program. So it's very modular. This shows an example of a multiple move rung. On the top branch, there's a box ready contact. And if this is turned on, it's going to queue up the motion after it on that branch. The second branch will always execute because there's nothing in front of it. But I'm showing this because I want to demonstrate that you can switch in motion with a tag on the same rung, if you need it or not. It's very easy. So let's say the box ready tag is on. The user frame 5 will be set active, and then the frame shift will be added based on a box number. There's an array there, shift array. And next you'll have a motion command that will queue up a point from job 0.5. On the second branch, there'll be an active tool set to 7, and you'll have 2 more motion commands that will be queued up. The motion actually starts after the AOI's queuing is completed. Each of these move commands has a % complete output. So the example here shows that the last move, when it's 75% complete, the gripper will turn on. And then when it's 100% complete, as indicated by the PC bit, the logic will move to the next step. And a ladder logic program is much easier to debug because you can see all the IO variables, IO numbers, the variables, the status, condition status, and the logic all in one screen. You don't have to go between different screens to see everything. It's very easy to look at and debug. One large benefit of the MLX300 is that it's very easy to add multiple controllers to one PLC. Each controller can have up to 4 robots. However, most customers just use 1 robot per controller because it's easier to configure. In this case, you don't need the DR2C kit hardware. It's just all you need is an Ethernet connection, and you got a second controller hooked up. Currently, the MLX300 setup is a maximum of 4 controllers. However, our Drives and Motion group in Waukegan has a customer with 7 controllers connected to 1 PLC. This is the reason for this. The load on the PLC is low because the PLC is just sending target positions to the controller, and the robot controller is generating all the motion profiles and control loops. And then now a single PLC can operate multiple robot controllers in the same cell, or it's easy to do it in different cells with extra wiring, safety wiring, of course. Any of the AOIs can be used for multiple robot controllers by just changing the MLX number at the bottom of the AOI. For the command shown, the MLX2 refers to the third controller, and the screens also be updated on the HMI to have a new entry to select the controller number. All right, so now I got everybody up to speed on the MLX300 configuration and programming. Now I'd like to proceed to the highlight of this WebEx, and that's to introduce the new MLX300 teach screen on the robot Pendant. In the past, MLX300 customers were required to buy a second Pendant to teach points to the PLC and for other operations. The choices were a ProFace Pendant, a mobile view, and you could even use a panel view with an enabling switch. This increased our system costs by $4,000 to $8,000 for the Pendant and the interface hardware. For some customers, this extra cost lost potential orders. So to help our partners, we developed this MLX300 teach screen on the robot Pendant, so the second Pendant is not required anymore. And this shows you how to access the MLX300 screen. There's a MLX teach button in the lower right-hand corner of the Pendant screen. When you press this, it's going to launch the Pendant app to bring up this teach screen shown on the right side. And every time the Pendant app is launched, the first 10 tools and the first 10 user frames are transferred from the controller 0 to the PLC. The reason for this is now because everything can be set up on the robot Pendant. So this information needs to be sent to the PLC so they can activate tools and user frames in the ladder logic and needs to know what's been taught. If you have multiple controllers or you need more than 10 user frames, the standard HMI, or you can even use a PC to create the extra frames. There's a way to use a PC and a robot Pendant. You can actually jog the robot around the PC with the robot Pendant enabling switch. You can disable the communication on the Pendant. It's all in the manual. It's pretty easy to do. So you can use a PC actually to teach points and user frames. Note that the interference zones data doesn't get sent to the PLC. However, the PLC can still prohibit an entrance into the zone until the conditions are correct. When the MLX300 teach screen is launched, there's a reminder showing that the first 10 tools and user frames are being transferred. You got to always remember that if you teach one of these items, you have to access the screen to download the information before you run your job to get that new information in the job. Now let's talk about each item on the MLX300 teach screen. The top right corner shows the status indicators. The first one is jogging coordinates. For those of you who don't really know, are not familiar with the robot Pendant, there's a coordinate membrane button on the keypad, and when you press it, it will change jogging coordinates from joint to world. World is actually Cartesian, and then to joint, to tool, and into user frame. So you can change between those 4 jogging coordinates. The next indicator is jogging speed, and this is also changed on the robot keypad. Then the last indicator is execution and e-stop status. I know some customers that are attending this WebEx aren't familiar with robots and its Pendant. So I wanted to identify the Pendant keypad and show which buttons are used with the MLX300 teach screen. There's an up and down arrow key, and that can be used on any field to change the number. And then we already discussed the coordinate button. The area key can be used to move the cursor between the fields. And then servo on and jogging keys in the middle are used to move the robot. And then the interlock key is used quite a bit. It must be pressed at the same time MLX push buttons are pressed. This prevents the accidental pressing. You know, if you accidentally hit it, you don't want to delete a point. You got to hit this key at the same time. The forward button is used to move the robot to a top position. So let's go through. Before teaching a point, you would select a teach list number, a point number, a tool number, and a coordinate type. The coordinate type could be a user frame number or the base. The base is actually the world. Note that the teach list number is the same as a job number on the older generations that are in the PLC tags and also in the old MLX HMIs. Really, a teach list number is more descriptive, a better description than a job number. Below that, you'll see you can enter a name for the teach list of points and a name for the particular point you're teaching so you can identify it easy later. When you do this, a keypad is going to pop up and you can enter a name and you can enter the name, of course, and save it. But once the names are all entered, it will not be sent to the PLC until you teach a point. So entering the names, you might lose it if you don't teach the point. So, and if there's no name entered, there'll be a default name with an item number. And that's shown on the right side. For example, teach list number 2. That's going to pop up, as it gets shipped to you. You don't have a name in there, so it's going to tell you it's teach list number 2. But you could change it to something like called palletizer. The selected points data will be shown on the left side. For this case, it's blank because it's not recorded yet. On the right side, you'll see the robot's current position. And above that, you'll see a message bar that now states that the teach point list is empty. Nothing's been taught yet. Note that if you change the tool number or the user frame number above, the current position data will change. But of course, the robot's really location and pose did not change. It just is reformatting the data so it has a different user frame. On the lower right-hand side, there are push buttons to teach a point and to maintain a clean list of points. The interlock button on the keypad must be pressed the same time these buttons are pressed, so you don't have an accidental pressing. These buttons can be used to create a clean order of points that corresponds to a sequence of motion. The clear button will erase the points data. This is for if you have a point you taught before and it's not used, you want to get rid of it to clean your list up. You can delete it or erase it. And the insert point can be used to insert a new point in between existing points. It will shift the data of the selected point and all the points above it up by 1. And a delete point will do the opposite. It will shift all the points above down by 1. And at the bottom, you have a clear list button that would delete all the points in the list to start fresh. While you're teaching points, there's an option to turn on any 4 PLC or robot controller outputs. This can be used to turn on a gripper, a conveyor, or any other device in the cell. The green indicator shows that which outputs are currently turned on. So you change the number and you do an interlock, on, and it will turn on. As a default, we have the 4 outputs on that screen mapped to the first 4 controller outputs. This can be modified in the output channel assignment routine to control any PLC or any robot controller output. When you're not in that screen, you might still want to turn outputs on. So there are hot buttons on the Pendant keypad that can quickly turn on and off outputs. By pressing the interlock button and one of the 12 buttons shown in the lower right-hand corner, you can turn on any output for a PLC or the controller. And for instance, some of the buttons are labeled. The number 2 button says tool on, and the period button says tool off. So you can set these keys up to for the gripper output control. So let's teach a point now. It's time to teach a point. So the first thing you do, you select a teach list number, a point number, tool, and a coordinate frame. Only the frames that were set up will be shown. And then you would press the interlock button and the teach point button at the same time. After teaching a point, the selected point and the current position data will match as shown in this picture. If you like to jog to the selected point, you would press the servo on ready, squeeze the enabling switch, and press the forward key. And then the robot, when it reaches the position, you let go. You got to the point, the data will match up to show you're there. So it's very easy. And then for this new MLX solution, the robot pendant can also be used for play mode operations. The green start button on top of the pendant, you can press it to start the PLC's job. And the white hold button can be pressed to pause the program's execution. To restart the program, you just press the start button again, and the program will continue where it was paused. After pressing the hold button, there might be a case where you don't want to continue the program. So for that, you can go to the Pendant's IF panel, and you can flush the motion cue and reset the program to start at the beginning. Right now, there's currently 3 ways to start the PLC's program. You can use a start button on the HMI, which is a user program start tag. The second choice, the new choice we have now, you can use the pendant button on any of the robot pendants, the start button on top of it. And the last choice is use a start signal from a dedicated external input, which could be a button on a fence. For play mode operations, you need to access the IF panel by pressing this button on the bottom of the pendant screen. It says IF panel. Before using the screen, the 4 blue indicators must be on. The first one is a heartbeat for the PLC to say it's communicating. The second one indicates the robot pendant key switch has to be in a remote mode. And the third one shows that the MLX mode switch is set to auto. The square buttons on the screen will not function until you switch the operation switch that's in the right top corner and set it to permit, PERM, P-E-R-M. Note that you have to hit the interlock button the same time you're pressing this to change it. But that, again, prevents accidental presses. So when you come in the screen, you got to do it one time at least, and you come back in, you're okay. It's just after a reboot, you got to turn this on. To start the program, you'd press the servo on button and to turn servos on, and then press the green start button on top of the pendant. Now, in the case where if you press the hold button on the top of the pendant and you don't want to continue the program, you'd come to the screen, of course, and you'd press the abort button and then the reset button to flush the motion cue. This will also reset the program to start at the beginning. There's a yellow motion buffer indicator, and this warns you that there's motion still queued up. So you don't want to continue. You want to make sure you flush this out. And there's also an HMI message indicator to signal the robot, signal the operator to look at the HMI on the for a warning message. It's indicating there's a warning message to look at for more details. Now, with this new MLX solution, you'll have the option to set up tools, user frames, and interference zones with either the MLX300 HMIs or the robot pendant. Both methods are well documented in the MLX300 manuals. You don't have to go between different manuals to figure out how to do this. It's all documented in the manuals for the MLX. And we do have, for the case where you have one method used to set up the user frame, there's software protection that would not allow the other method to overwrite the data. For example, the MLX screen on the left side shows that user frame 3 has not been set up yet. It's all zeros. So this HMI can set this user frame up. However, on the right side, it shows that user frame 1 has already been set up by the robot pendant. And for this user frame, the top data can be seen but not changed. You don't want it to be overwriting if one set it up already. If you do want to change it, you can always go and delete, clear out the data on the other device, other method, and then the user frame can be taught on either device. Now, for user frames, there's only for interference zones. For interference zones, only one method should be used all the time, because the controller never transfers the IZ data to the PLC. And for this reason, it's not possible to detect that the robot pendant set this IZ up. So you need to know that. I mean, so in this case, you probably want to stick to one method. You don't want to go back and forth. Now, there are some functions that are not currently supported by, with the MLX T screen. If your controller will be using Ethernet safe, the MLX T screen cannot be used. Explicit messaging will not work with the Ethernet safe option. For controllers with multiple robots, the MLX T screen can really only teach points for the first robot. There are plans to expand this functionality to the other robots, but this will be a future development. But if you do have multiple robots and you have one robot per controller, you can teach positions for all the robots. However, keep in mind that the first 10 tools and user frames are only transferred from controller 0. You might need to use an MLX HMI or a PC to set up user frames for the other controllers. And the last item not supported with the MLX T screen is a base axis or an external axis. Now, everything on the screen will be supported in the future, except for this Ethernet safe option. I just wanted you to be aware of what's not supported now at this time. The Motoman website has some great MLX300 tutorial videos. They can be found under Products, Controllers, MLX300 Tutorials. And I just posted a new video on the MLX300 T screen that shows more detail and actually a simulation running and everything to show the interaction better. And there's other videos for basic MLX operations and advanced debugging. I'd like to thank everybody for taking the time to hear about the new cost-saving feature of the MLX300, and I hope it'll be very beneficial for your future projects. At this time, I'm ready for any questions.
Okay, John, we've got a few questions. I'm going to just go ahead and pop those up on the screen here. When using the Pendant, does it support a 7th axis?
That's a good question. We haven't had that case yet. I believe it does, but we haven't had that case. We don't use it for the 7. Oh, you mean for an external axis? I thought you meant a 7-axis robot. Yes, it'd be an external axis. It does. That's a transporter, a base axis. I was thinking a 7-axis robot like we used to have a couple of years ago, but yes, it does.
Can you read position variables to from the controller? Same question for other types of variables. Can you access controller I/O?
Oh, yes. It's variables to the controller. The variables are all in the PLC, but you can write to you can see on the PLC ladder. You can see all the inputs and outputs, and you can control those from the PLC. But the variables stay in the logic of the PLC. The robot doesn't need these variables. The robot should just get the I/O commands for setup and for moves. So yeah, variables don't go to the robot controller. Actually, we do have AOIs that can command, integers and bytes to it, but there's no real reason to because there's no robot job running. So it's all in the PLC.
All right, and Sam had a second question here. When will the new AOIs be released?
That's a very good question. I'm getting ready to do a collision detect testing this week, and we could have it released here pretty soon. Let me know if there's a need to have it, by a certain date. We'll have it ready for him. Which AOI is he interested in?
He didn't specify in the question, but I've got his contact information from the chat log, and I'll connect you to.
I tell you, the brake release and the collision detect is complete right now by Yaskawa. We just haven't done the full validation of it yet. Our group in Europe has, and they say it all works fine. I just want to validate it first and put it in our software. The circular motion, I know they're still working on it, and the servo float, they're still working on that, but it's coming soon. It'll be down the road more, probably maybe early next year for those two.
Very good.
But the other two are ready now. I just need to do a validation. I can get in the ladder pretty quick.
Does the MLX300 work with pallet solver?
Yes, and that's a good question. We just had an integrator use MLX pallet solver to palletize 96 different SKUs onto 2 build stations And the product changeover time was less than a minute. And they went so well, they're buying a second system right now.
All right, and let's see, I jotted one down here. Can the smart pendant be used for MLX300?
Not yet. That's another good question. There is a current development schedule. They're working on it, and we'll be porting over the MLX300 touch or teach screen to the smart pendant in the near future. I just don't have a date on when that could happen. It depends on the balancing of our schedules.
Okay. I'm looking through the chat log. I don't see any other questions. Last call for any questions anybody might have. Any questions at all for John? Okay, not seeing anything. We'll wrap things up. Just a reminder, you can view our past presentations and register for future webinars on our website at motoman.com. Go to the About menu and Webinars. You will receive an email in a short time with a link to replay the recording of today's webinar, and it'll also be listed on our website in a few hours. We hope to see you again at our next webinar on September 9th at 2 p.m. The subject is Intelligent Robotics and the Modern Supply Chain. We'll have a guest presenter from Mujin. As always, we want to thank you for spending part of your day with us, and we'll see you again next week. Thank you, John, for presenting today, and we wish everybody a great day.
Thank you. All right.